Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, today's discussion will be about the development of a sphere, and as we have already discussed that development of the sphere is not possible by using the conventional development techniques. So here we are going to use approximate method for making development of the sphere. Now the approximate method is used to develop the objects of double curved or wrapped surfaces such as sphere, paraboloid, ellipsoid, hyperboloid and helicoid. Now you see there are two methods, that is zone method and the Lune method, through which we can go for the development of the sphere over there. Now in both of these methods, the surface of the sphere can be approximately developed by dividing it into number of parts over there. So you see here once again, these are two methods. In the first method, you see we call it zone. So zone means that we are going to divide the sphere into different zones and we are going to cut it in such a way. You see there is the vertical axis of this particular sphere over there. So all the cutting planes, they will be perpendicular to the vertical axis of this particular sphere. And what is going to happen, you see the topmost portion of this sphere which has been cut over here, this will be treated approximately to be an approximation of a cone over there. So the development of the topmost portion will be done as per the development for the cone. Then the remainder, you see the remainder segments, there can be 3 segments over here or the 4 segments up to the top hemisphere. We are going to develop top hemisphere of this sphere, that is 50% of the sphere, and the development for the remainder 50% will also be the same. Okay, so here you see the topmost portion, you see it is containing this spherical portion. So as an approximation, we will assume that this is the axis and we are going to join this over here and it will approximately work like or behave like a cone. So the development of the cone corresponding to the topmost layer or the topmost zone will give us the development of this surface. Next, you have cut this sphere in such a way that again there is a curved surface over here. So again this will assume to be the frustum of a cone. If you join these two ends, so this frustum of a cone will look like this, and whatever development of this frustum of the cone will be there, this will give us the development of the second segment or the second zone. Similarly, we will be having a third segment or a fourth segment till we reach the center of the sphere over there, right? So we can divide it into 3 or 4 zones over there, and whatever, and again the third segment or the fourth segment will also be treated like the development of the frustum of a cone. So the first will be the development of a cone, first segment, second, third and fourth segments will be divided into zones, and those zones will be developed as per the development of frustums of the cone over there. So this is the first method which we call as zone method. Now we have the second method, in which once again we are going to divide the surface of a sphere into number of segments. So we can divide the segment into 8 equal segments, 12 equal segments and then 24 equal segments. So let us say we divide it into 12 equal segments. Now these segments, they are unlike these ones, so where the cutting planes happen to be perpendicular to the axis of this particular sphere. In this case, the cutting planes, they are aligned in such a way that they are going to pick up one lune. So what is this lune? So lune is basically the zone of the sphere which has been removed or which has been taken out by the cutting planes, which are aligned such that both of these planes, they are passing through the axis point of the sphere. So in a radial manner, you see we have cut this particular component or we have cut this particular lune or the portion of the sphere. So once we remove one portion, you see, and we say that we have divided it into 8 equal parts or 12 equal segments over there. So each segment will be called a lune. So the development of one segment will give us the similar development for rest of the 7 or rest of the 11 segments over there, right? So this way, once again, we have divided the sphere into certain number of parts or the components. So the development of one part over here will give us the development of the rest of the parts, whereas over here the development of 3 to 4 segments or zones need to be made, so that the remainder of the hemisphere will also be giving us the similar development of the remaining portion of the sphere over there. So this way, because we are going to assume that this portion is just like a cone, this portion is just like, you see, once again, frustum of a cone over there. So always there is going to be certain amount of approximation. So that is why we say that this is an approximate method for development of the sphere. Now, first method that we are going to discuss today is about the zone method for the development of a sphere. So here you can see we have divided the sphere into 4 segments over here, and all these segments, they have been worked out such that the width of each of the segments should be equal. So this is the width that we are talking about. And another thing, if this is the axis of the sphere, then all the cutting planes, cutting plane 1, cutting plane 2, cutting plane 3, cutting plane 4. So all these cutting planes, they will be perpendicular to this vertical axis, or otherwise also we can say that all the cutting planes, they will be parallel to the horizontal axis of this particular sphere, because all these cutting planes sections, they are parallel to the horizontal axis, or the cutting planes should be perpendicular to the vertical axis of the sphere. So you see, one half of the sphere we are going to develop, and the remainder half development will be the same over here. So just see here again, zones they have been formed over here, and these are the cutting planes which are going to cut this sphere into equal number of parts over there. And you can have, here we have assumed that we have divided it into 4 zones. You can divide it into 3 equal zones also. If the sphere size is small, we can divide it into 3 equal zones over there. So what is a zone? Zone is the portion of the sphere which is enclosed between 2 planes perpendicular to the axis. You see, these are the different planes. So the area between the portion of the sphere which lies between these 2 planes, we call them zones. So these are all the zones of, you see, these are all the zones. These are the zones of the sphere. Okay, so we are going to divide the top half of the sphere into 3 or 4 zones, and we can name them A, B, C, D, and they should be of equal width in the front view. You see, the width should be equal in the front view, even if we are dividing it into 3 zones. So again, the width should be kept to be equal over there, and each zone becomes the frustum of the cone. That is, the lower zones, you see, they become the frustum of the cone, and the top zones, this is the top zone. So the top zone will be treated to be just symmetrical to a cone over there. So the development of this portion will be done as if we are going to approximately assume that the uppermost portion of the sphere behaves like a cone, and this development will be based upon the development of the cone. Whereas development for rest of the segment, there can be 2 segments, there can be 3 segments in the upper hemisphere over there. So these will be done, the development for the remaining segments will be done as per, once again, an approximation that this sector behaves like a frustum of a cone. Again, this segment, second zone, it again behaves like, so you see, frustum of a cone. And again, this, for this particular, you see, D zone, once again, we are going to draw through these corners slant edges, so that once again a frustum of a cone will be obtained over here, right? So once again there is an approximation in this particular case. So each zone becomes the frustum of a cone except the uppermost zone, which becomes a small cone with a small altitude. So here the altitude is small, so this is a cone. This is a cone which we have to carry out development. So let us see first of all the development of frustum of a cone and development of a cone, because these 2 developments we have already discussed in our previous lecture. So here you can see this is the development of a cone as well as a frustum. So this is my true length. You see, this is my true length. Why this is my true length of the slant edge? Because this radius in the top view will be parallel to the XY reference line, or it will be parallel to the vertical plane. So in the front view, this slant edge, that is only the outermost slant lengths over there. So these two lengths, they will give me the true length of the cone, the true length of the slant length of the cone, slant generator of the cone. So once I know this true length of the slant generator, that is L, now with this as center, I can draw an arc over there, and depending upon the radius that I have worked out, so I can mark the points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. So all the points from the top view corresponding to the different sectors, they can be worked out, and I will be getting, this is the development of a cone over there, right? So this will be used for the uppermost segment, that is the first, you see, layer from the top which has been removed. But for the rest of the layers, once again, this portion we assume that this portion of the cone has been removed, so this becomes my second cone. So in the second cone as well, the slant length of the generator, so this is my true length. So I will be measuring this length, that is corresponding to the removed portion, and then I will be drawing another arc corresponding to it. So this will give me, you see, this sector which has been cut will give me development of the frustum of the cone, whereas this one, it was the development of the full cone over there. So we had used this frustum of the cone development in another example. So this case we discussed in our previous lectures. You see, here we had a funnel arrangement. So in the funnel, this was the total cone. We extended this funnel to make it look like a cone, right? So same thing we are going to do in the zone method. For the second, third and fourth segments, so we are going to assume that whatever portion of the sphere is there, we are going to extend the two corners over there, and then we will make it behave like a cone. And then this will be our slant edge, and then we are going to draw an arc through this particular apex point equal to the length of this longer slant edge. So this will give us the outermost portion of the arc. Then we know the segments. So this segment length or width we are going to mark, and then 12 segments we are going to draw over here. Then corresponding to the removed portion, you see, we are going to mark another arc, and then the interior, you see, segments will be corresponding to the smaller diameter circle over there. So this problem again we have discussed in the previous lecture. So these two cases we have already discussed. So with this background, let us start working on the development of the sphere using the zone method. Now here we are required to make the development of a sphere which is having diameter of 50 millimeter using zone method. Now you see, here we have a sphere, and this sphere diameter will be 50 millimeter. Okay, so now we have divided this into 3 segments. So I haven't divided it into 4 segments because procedure remains the same. And you can see the width over here, width second and width third, so they are equal to each other. So width of first segment, second and third, so they have been marked to be equal over there. Then segment A development will behave like a cone. So because it is an approximation, so I am going to join this, I am going to join this part. Now corresponding to these 3 circles, basically, because these are the 3 segments, I have assumed that my hemisphere lower portion over here has been divided into 3 segments: segment A, segment B and segment C, and these are my cutting planes over there, and I need to draw the top view of this. So in the top view, you see, I need to draw this top view at a distant location. Reason, because I will be joining these 2 points over there to be behaving like a cone. Similarly for this also, while I am joining this, you will find that the length of this particular slant edge for the cone will be very long. So if I draw both of these front view and the top view close to each other, so it might happen that the projections of the slant edge, they might enter into my top view over there. So I wanted to show distinct front view and the distinct top view over there. So that is why I have kept reasonably good amount of distance between the front view and the top view. Now you see, corresponding to all these, you see circles over there. This circle was there, this cutting plane was there at the axis point. So this circle will be represented by the outermost circle in the top view. So even if you cut this sphere into 50%, so whatever diameter of the sphere will be there, it will look like a circle, because sphere, if you cut from any orientation in any position, the view which you are going to obtain for the cut surface will always be a circle. So if I have cut it from the center, so this is my projection in the top view. I have obtained a zone or a slice for my sphere at this position. So corresponding to my cutting plane number 2, I have changed the color. This is the red color. So corresponding to blue means it is the outermost portion at the diameter. The second cutting has been done over here. So for this segment, so you see the color of the circle has been red over there. If this is red, this is red, this is blue, this is blue, and this is greenish. So corresponding to this portion, you see my circle over here will also be greenish. And you see these projection lines, they are going to give me an indication corresponding to the first cutting plane. My circle or the divisions applicable will be corresponding to greenish circle over here. Corresponding to second cutting plane, my circle which will be applicable, or the division, 12 divisions which will be applicable, they will be for the red color circle. And corresponding to this portion, diameter portion, third cutting plane, my outermost, that is blue segments, they will be required. Now you see, I am going to divide this top view into 12 equal parts. So once I divide it into 12 equal parts, you see I have got the numbering. So each sector length is equal to 30 degree over here. So these are the 12 portions in which I have divided, and correspondingly for the red circle, again the divisions I have not shown because that will create confusion. So many points I have to locate, but for your reference I have located, this was 1. So this is the first inner circle. So 1 1, 2 1, 4 1, sorry, 7 1 and 10 1. Corresponding to the second cutting plane over here, so I have marked the corresponding points as 1 2, 4 2, 7 2 and 10 2, and in interior portions they will also be similar. So please check. Now all the line segments are there, so I need to measure this. So obviously 7 8 9 will be there. This is 10, so this will be 11, this will be 12, right? So on the outermost circle I have shown all the points over there. Now I have divided this circle into 12 equal parts. Now I need to start making the development. Now as we had discussed, you see this is my first slice. So whatever first slice is obtained, so we are going to assume that this is again using approximation method. So this slice will behave like a cone, right? So the development will behave like a cone. So if we say this is a cone, so this is my slant edge, please check. This is my slant edge 0 1, this is 0 1 2, and this is 0 1 7 2. This is 0, this is O, O means the axis, O, this is 1 2, this is 1 2 over here. I can put a dash also. This will be O, this is O, then 7 2, this is 7 2 dash, right? So points I am not making because otherwise so many points will complicate the things. So here these are the two slant edges. So because we have already known by now how to make development of a cone. So for the development of a cone, two things are required. Number 1, true length of the slant edge. I have that. This is my true length of the slant edge. So using this as the apex point, I am going to draw, you see, a circle over here like this. I will be drawing a circle over here like this. So please check. I have drawn a circle using O as the center, apex point, and then I need to make all these segments over there because all these segments corresponding to the innermost circle. So these segments will be smaller. Please check. These segments will be smaller. So this is 1 2, this will be 2 2, this will be 3 2, 4 2, 5 2, 6 2, 7 2, 8 2, 9 2, 10 2, 11 2, 12 2. So I need not mark all these points. Reason, one sector is equal to the remaining sectors over there. So whatever is the width for the first sector, same will be the width for the remainder of the sectors over there. So what I am going to do, please see, I will be making this distance. Okay, I am going to measure this distance over there, and once I measure this distance corresponding to one sector, I am going to draw starting from here 12 arcs. Arc number 1, arc number 2, arc number 3, arc number 4, so on till I reach 12 and then get back to 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then 1. So let me do it. I know the sector width over there. Just see, this is my point 1 corresponding to the green circle. Corresponding to the green circle, one sector I need to measure, because all other sectors, they are also equal. Now starting from point 1, I have drawn first arc, I obtain point 2. I have drawn second arc, I have obtained point 3. So this way, one by one, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then again 1. 1 will lie here. So I started from 1, I have ended at 1. So this gives me, you see, if I just join this, this gives me the development of the first portion, first segment, which was sliced over there. So the first segment, I have assumed it as per the approximation method that it behaves like a cone. So the development of the smallest cone, which is having very low, you see, altitude value, has been done over here. Now second, you see, this is the second slice. So I am going to assume that I join this point with this point. I am going to join this point with this point. Again, it is a curve, but as per approximation method, I am going to join both of these points straight. So let me join it. So this is development of segment A. Now I am moving on to segment B. So in segment B, you see, first point and second point on this side, they will be joined and projected. First point and this point on the second side, they will be joined and projected. So this gives me, you see, the slant edge of frustum of a cone, because I want to make only this development. The upper part development I have already made. Now my frustum of a cone is this one, you see, frustum of a cone for the second segment, right? So I want to make development of this, so I have extended this, I have extended this. So this is my frustum, and we very easily know that what is frustum of my cone development. This is my true length of the slant edge. Why this is the true length of my this slant edge? Why? Because you see, this is my second cutting plane. So this is red color. I move on to the red color circle, that is second circle over here. So in this circle, center, that is O 211 and center, that is O 271. Both of these top views, they happen to be parallel to the XY reference line or the vertical plane. So therefore, these slant edges, outermost ones, they will represent the true length of the slant edges over there. So this one, you see, starting from here up to this point, this is my complete length of the cone, uncut cone, and this is the length for the cut cone over there. This cone has been assumed to be cut over there. So this portion we are going to assume this has been removed, and this was the original cone, right? So now this is our slant edge for the uncut cone. So what I am going to do, please check from here. I'll open compass equal to this much. Again I repeat, I am going to open compass this much, and once I open compass equal to this radius with OS center, now my center is this. Earlier my center was this. Here my center is this one. Because my radius is there, this is going to be my center. So with this as center, I'll open the compass this much and draw an arc. Draw a bigger arc. Similarly, this is the second cone which I have. This is the second cone, and in this cone also, this is going to be my true length of the slant edge. So this is for the second cone. You see, this is second cone. So for the second cone, this is my slant edge, which is true length. And again, using this slant edge length, radius, I have drawn second arc over here. Now what I need to do, corresponding to the red circle, now please see, corresponding to the red circle, now I move on to circle number 2. So now I will be marking this distance 1 1 to 2 1, 3 1, 4 1, 5 1, 6 1, 7 1, 8 1, 9 1, 10 1, 11 1 and 12 1, right? So all these sectors, they are equal, so no issue. I will measure the distance between 1 1 and 1 2. This is 1 1, this is 1 2. So this distance I am going to measure where? From here. So I'll be starting from here once again, just like this. Again 1 2 3 4 5 6 7 8 9 10 11 12 and 1. So start from 1, go to 12 and then get back to 1. So let me do it. Please check this out. My starting point is 1 for the second zone. This was first zone. This is my second zone. So again, starting point will be 1. Using this as the radius, please see. Using this as the radius, I have drawn the arcs. Now, how much is this distance? 1 to 2. And similarly for the rest of the point, equal to this sector chord length. So corresponding to this sector, measure the distance and mark all the 12 arcs over there along this particular curve. Third, fourth arc, fifth arc, sixth arc, seventh, eighth, ninth arc has been drawn, 10th arc has been drawn, 11th arc has been drawn, 12th. I need to get back to 1. Why? I started from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then 1. So from 12 I need to get back to 1 also. So then I will be going to 1. Now this portion you see, which I have obtained. So this is the development of frustum of the cone up to this point. Okay, this is my end point. So this is the excess length which I could have trimmed over there. So excess length you can trim, but development will end over here. So this segment will give me the development of frustum of the cone corresponding to zone number B, right? So this is my zone number B. Now I move on to zone number 3, which is my zone number C. And as I told you, you join this point of the zone with the second point of the zone, starting point, end point. On the other side also, I have assumed that this is first point of the zone, this is second point of the zone. Join them. Now this is blue color. So first was green, second was red, third is blue. Now you see, extend, join here, again extend and join here. And this is the reason I did not draw top view closer to the front view. So had I drawn top view closer to the front view, so this would have protruded into this particular zone. So once it intrudes into this, so the clarity would have, you see, diminished over there. Now you see once again, O1 corresponding to blue circle now. Now I started with green over here. I moved on to red over here. I have moved on to now blue color, outermost circle, corresponding to the diameter of the circle. This part, third zone. Now over here, please check 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. Now please check corresponding to this. This is my center O. So O1 and O7, they happen to be parallel to the XY reference line, intermediate XY reference line. So since O1 and O7, they happen to be parallel to vertical plane or the XY reference line, therefore O dash 1 dash and O dash 7 dash, that is this slant length, this is my true length of this slant generator O1 or O7. Okay, so this is true length for slant generator O1. This is true length for slant generator O7 over here. Now once I know this true length, no issue. This has my center, this is my point O. I'll open up arc up to this much. I am going to draw first arc. Similarly, for the cut portion of the cone, because this portion of the cone we have assumed that this has been cut. You see, this is the portion of the cone which has been cut from the bigger cone, so that you get the zone over there. The leftover portion will be the zone, right? So this was the bigger cone. This is the bigger cone. From this bigger cone, if we remove the smaller cone, so obviously the remainder portion will be a zone over here. So the development of the zone will be obtained, and zone we are assuming this is frustum of a cone. Now here, this is my true length. I have drawn an arc corresponding to the true length. This is my true length for the smaller cone. This is my true length for the smaller cone. Why? Because this is again corresponding to the red line. So for the red line as well, O11 and O71, this was also parallel to the XY reference line or the vertical plane. So this is also true length. So corresponding to bigger true length, outer curve is there. Corresponding to the smaller true length, the inner curve is there, just like we had drawn over here. Now, two curves have been drawn corresponding to the bigger, you see, slant length and smaller slant edge length over there. Now, this point will be 1. Okay, so this point will be 1 now. This is this one over here. So from 1, once again, which arc I am going to measure? This one. So earlier in the first case arc was this. In this case, in the second case, red one, this one, arc length was this, corresponding to red color. In the third case, arc length has increased because the diameter of the circle has increased over here. So now this arc length I have to use. So corresponding to this segment 1 to 2, the bigger arc length will be there. So starting with this as my radius, that is apex point, I am going to draw multiple arcs. So from here, I am going to join all of them radially thereafter. You see, first arc I will be drawing from 1 over here, join it radially. Again, you cut second arc from 2 to 3, again join it radially. Again cut fourth arc from third point, and this way keep on cutting 12 arcs over there. So fifth arc, sixth arc which has been joined radially, 7th, 8th, 9th, 10th, 11th, 12th, and again get back to 1. So you see, if you end up at 12, 11 arcs will be available, 11 segments will be available. So you always, your starting point and your end point should be the same. So first, second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th. So 12 segments we have been able to achieve. Now this is the development for the third zone. So this way, this is the development of the first segment, this is the development for the second segment, this is the development for the third segment, which is segment C. So this way we have been able to develop the sphere using the zone method. And again, as we have seen through this discussion, that at number of places approximations have been made. So this method is called approximate method, right? So same thing we have drawn, the students they have drawn. You see, we have divided this into 4 segments. So the first segment behaves like a cone. So we haven't completed this, we have to go to 12 and then get back to 1. But the procedure has been elaborated over here. So 6 segments we have shown, remaining 6 we can continue. Over here also 6 segments have been shown, so we could have continued with the remaining 6 segments, but the procedure remains the same. You can see I have divided this into 4 segments, and the 4th cone intrudes into my top view. So that is why large distance should be kept between 2 views over there. Okay, So there are few more solutions which are available in the literature. So again you can see 4 segments they have been made. So this is upper part of the sphere which has been developed. So this is development corresponding to the lower half of the sphere. So same as we have discussed. Again another one is there. First segment, second segment, third segment and fourth segment. So the same development we have discussed. So this is only the JPEG image which we have been able to obtain from the literature. So this way we have been able to complete the development of the sphere using the zone method, where we have divided the sphere into number of zones which can be 3 or 4. So this way the sphere can be developed using the zone method. So in the next lecture we are going to discuss about the development of the sphere using the Lune method. So this is all for today. So thank you very much. Thanks a lot.